Okay, this video is going to take the concept of segment addition postulate, if you're familiar with that, and apply it to angles. So we're going to start with, we need to be able to interpret what we're given and draw pictures having to do with angles. We've got S is in the interior of angle PQR. So let's draw an angle. Whenever we name an angle, the middle letter of our three letters is the vertex point. So we are going to have a Q for our vertex point. P and R, doesn't matter, put one on each ray. And that's angle PQR. The interior is anything inside of the angle between those rays. So we can go ahead and I'll show you that's all the interior versus exterior would be what I'm highlighting in green here. We're going to put a point somewhere on the interior and call that point S. So here's going to be my point S right here. And I'm going to go ahead and draw a ray through that. Okay, there's your picture. We're going to draw a lot of those pictures as we work through a couple problems here. The angle addition postulate says that we can have our same equation that we've been using. Part plus part equals whole can be true with angles as well as segments. So if we're looking at this picture, we've got angle PQS, this one over here, is one of the parts of this picture. Angle SQR is next to it. And if we take angle PQS, we add angle SQR to it, then we're going to get angle PQR. We're going to have this entire amount here. That is our whole. Okay, just as a quick little side note, sometimes when you see this written, you're going to see a little lowercase m in front of your angle markings, and that's just referring to the measure of the angle. So it doesn't have anything to do with the actual angle itself or the letters that we use for it, just to let you know that. Let's go ahead and work through an example, and all we're going to do is we're going to actually plug in some expressions and solve for angle measures in this one using our equation part plus part equals whole. If you want to go ahead and try it, go ahead and try it and then check your work. You can pause the video. I'm going to talk you through it. D is on the interior of angle ABC, so I'm going to draw almost the exact same thing that I drew up above. Remember again, B is the vertex point. I know that by looking at my angle, and it's the middle letter. D is on the interior. A little bit quicker this time because you know what you're doing. And I'm going to go ahead and label all my information. Measure of angle ABD is 3x. You'll notice I like to highlight them. Using different colors works well here. Measure of angle CBD is 2x minus 5. And measure of angle ABC, that's the whole angle. We're told is 150 degrees. Some people like to mark it out here, I've seen as well. Somehow you got to show that's the whole angle so you don't get confused with what's going where. And I said we should be able to use our part plus part equals whole that we have right here. So if I bring this down here, let's see if we can come up with two parts and the whole to put in here. It's looking like the whole was our 150. Sometimes I like to find that one first. And then the two parts, well, I've got the part on the left, 3x, that's angle ABD. And the part on the right, in my picture, angle CBD, is 2x minus 5. And if I get rid of this, I do have an equation now that I can solve for x, and then I can plug in to find the angle measures. Okay, I'm going to walk you through the algebra. 3x plus 2x. I'm combining my like terms. You're not changing signs. You're on the same side of the equation. Keep everything else the same. Now let's move our 5 over by adding 5. 5x is equal to 155. Might need to grab a calculator for this one. X comes out to be 31 degrees. Remember, we're talking angles now, so our units are technically degree measures. So x is 31. Just to check, let's go ahead and find each angle measure, plus it does tell us to do that in the problem. So over here, I've got angle ABD was 3 times 31. So if I go ahead and do 3x, 3 times 31, I'm getting 93 degrees for that. Angle CBD is 2 times x, I'm putting in 31 for x, minus 5. 2 times 31, 62, minus 5 is giving me 57 degrees. And we already know that angle ABC is 150 degrees, so we don't really need to do anything there. Good double check, take the 93 and add it to the 57, and that does come out to 150 degrees. That's a good indication that I am okay, that I did the problem correct. Everything works out in the end. It's angle addition postulate using angles. One other thing we need to talk about with angles is we have what we call an angle bisector. That term should look familiar. We've looked at a bisector before, but we looked at a segment bisector. So recall that bisect means to divide into 2 equal parts. So an angle bisector is by definition a ray that divides an angle into 2 congruent or equal angles. I like to put a picture with that, so let's go ahead and draw a quick sketch of that. Same thing I drew on the other side. This time a ray going through it, and whether it looks like it or not, if we know that that is a bisector, we know that we have 2 equal angles. So another way we can name angles is with the numbers in between. We now know that angle 1 is congruent to angle 2. I'm going to go ahead and mark that. We like to use a similar marking to what we use for the segment bisectors, or when we have a midpoint. We called those tick marks. This time we're going to call them arc marks. So arc marks show that 2 angles are congruent, or that their measures are equal. Okay, how does this help us? Well, sometimes we can do a different equation setup when we have congruent angles. Remember how we have that equation, which we can, I'm not going to fill it in right now, but we can fill in usually with the words part plus part equals whole. We have a second equation. Sometimes we can say things are equal and we just set 2 things equal to each other. Okay? When we have a bisector, we do know that the 2 angles are equal. So now we're now going to have 2 options. We might be able to use the equation on the left, or we might have to use the equation on the right. Let's take a look at this one and see where we're at. So I'm going to go ahead and draw a picture of TH bisecting angle ATM. Here's ATM, TH, bisecting it. I'm going to go ahead and mark it just so we know. Put those arc marks on whenever you see that word bisect. Now let's fill in our information. Angle ATH is 3x minus 2. Angle MTH is 9x minus 26. And notice this time we're not given any information about the whole, but we are asked to find the measure of angle ATM. But if I look at that, it didn't give me an expression for it. I don't have a number for it. We had 150 in the last one. Now I don't know the degree measure of that. So if I actually try to do my equation, part plus part equals whole, it looks like I have the 2 parts. I've got the angle on the left, I've got the angle on the right. I don't have anything for the whole. So that's not going to work. Instead, this time we're going to use our equation part equals part. Let's see what our 2 parts are. Nope, I've got angle ATH, which is 3x minus 2. And then I've got the measure of angle MTH, this one, which is the 9x minus 26. And I'm just setting those 2 equal. From there, it's an algebra problem. Walking through the algebra, I'm going to subtract 3x, giving me a -2. Don't forget to bring down the negative. Easy mistake to make. 9x minus 3x giving me a 6x minus 26. Keep going. I'm going to add 26 to both sides. Those cancel. 6x on the right. -2 plus 26. Watch your sign. It's going to give me a 24. Dividing by 6. Coming out with x is 4. And there's a really nice way you can check your answer here. I'm asked to find the measure of angle ATM. So I'm looking for the measure of the entire angle. I don't actually have just one expression I can plug into to find the measure of angle ATM, but I have the two parts, and we already established that if we add the two parts, we're going to get the whole. So I'm going to plug the 4 into both parts, and I'm going to check my work because I know since I have a bisector, they should be equal. Plugging in 3 times 4 minus 2, 3 times 4 giving me 12 minus 2, 10 degrees. Plugging in the 4 here, 9 times 4 minus 26. 9 times 4 is 36 minus 26, hopefully again giving us 10 degrees. I can now confidently say that the measure of angle ATM is actually the sum of those two, 10 plus 10, 20 degrees. Okay, and that's a basic example with an angle bisector. I'm going to do one more example. I want you to go ahead and draw this, try working through it, and then check your work. Because of the word bisect, I'm going to mark the parts equal. Check yours, make sure you did that as well. Angle PQT is 5y minus 1. Angle PQR is 8y plus 12. Be careful. Really look at your picture here. It's really tempting to put the 8y plus 12 right here, because that's the other angle that we don't know. But remember, there's 3 angles in this picture. There's the 2 small ones, and there's the bigger one. And if you look at PQR, PQR is out there. PQR is the whole angle. That is the 8y plus 12. Okay, or maybe you like to write it out here. That's fine. It's that entire angle that we're looking at. Whoops. So when I go to make my equation here, that's all I'm given. Remember, we've got 2 options. I like to start with this one because I have a bisector and I know that 2 angles are equal. So my initial thought is to go ahead and do 5y minus 1. That's one of the angles, and then do 8y plus 12. Let's go ahead and look at that equation. You're saying 5y minus 1, that's this angle, is equal to 8y plus 12, which is this whole angle. Does that make sense? Hopefully you're saying absolutely not. That's impossible. So what can I do instead? Well, it looks like the 8y plus 12 is the whole, which means that I'm going to have to go back to my other equation that tells me something plus something equals the whole, a part plus a part. And we definitely can confidently say 5y minus 1 is one of my parts. What is the other part? That is the trick of this question. You got to be able to figure out, what can I do with this angle? Okay, think about it. What do we know about that angle? Well, we got these tick marks. What do those tick marks mean? Tick marks mean the angles are equal. So if the angles are equal and the angle on the left here I called 5y minus 1, then couldn't I use the same expression for the one on the right? If they're equal, it's going to have to be 5y minus 1. If I can put an expression with that, now I have an equation I can solve. I have one angle plus another one, part plus a part equals the whole angle. And now it turns into an algebra equation. So let's go ahead and do the algebra. It sounds a little bit more complicated. Okay, a lot going on the left-hand side. So I'm going to go ahead and combine my like terms. 5y plus 5y giving me 10y. Minus 1 minus another 1 giving me minus 2. So I went ahead and combined both of those. Equals 8y plus 12, not changing that. Subtract my 8y, giving me 2y minus 2 equals 12. Now let's add the 2. 2y equals, 12 plus 2 is not 6. 12 plus 2 is 14. Dividing by 2. If you're coming out with y equals 7, I'm liking your answer. Y equals 7. Of course, I can know I'm correct when I'm plugging back in. The only question they ask is find the measure of angle RQT. So I really just need to go with my expression 5y minus 1. And the y value we just said was 7. So I'm going to go ahead and insert that in there. 5 times 7, 35. Subtract the 1, giving me an answer of 34 degrees, hopefully, for your final answer. Again, not a bad idea if you're doing this on your own to go ahead and plug in your y to the 8y plus 12. And if this is really double each of these angles, because we have a bisector, you should be coming out with 68 degrees. That's all. That's even a little bit more complicated example with the angle bisector. With those, you should be able to do any angle problem, whether you're using angle addition postulate or angle bisector. Good luck.